Hi, welcome back to Missing Chemistry. This is Colligative Properties lesson number 3. The boiling point of a solution is 100.75 degrees centigrade. What is the boiling point elevation of water? What is the molality of the solution? Okay, so what we want to know is a couple of things here. All right, so first of all, let's use the formula delta TB equals IKBM. All right, so let's get this done here. So what we know is that our boiling point of our solution is 100.75, right? So what we're going to do is we're going to take delta TB equals the boiling point solution minus the boiling point solvent. Okay, so we're going to take, so what this is going to be is delta TB is going to equal 100.75 degree C minus the boiling point of water, which is, of course, 100 degrees C. So our delta TB value is going to equal 0.75 degrees C. Okay, now what we're going to do is we're going to take that and put that into the formula. Delta TB equals IKB little n. All right, so this is going to give me 0.75 degrees C equals, then the Van Hoff factor for this is just going to be 1 because it's not an ionic compound. So the boiling point of IB for water is going to be 0.51 degrees C over M, which is the constant, times our molality. Okay, so we're looking for the molality here. So M is going to equal 0.75 divided by 0.51. And our molality is going to be 1.5 M. Okay, that's it for this particular problem. So let's look at our second problem here. Our second problem says if I add 1.65 liters of water to 112 grams of sodium acetate, what is the molality of the sodium acetate of the solution? All right, so let's look at that problem and let's think about it for a minute here. So now what we're going to do is we're going to have to first find the molar mass of sodium acetate before we can do anything here, because we need to have moles. Okay, solute. So let's see here. We got sodium, carbon, hydrogen, and oxygen. There's one here. So this is 22.99. This is 12.01. Where are they getting these numbers from? On the periodic table, of course. This is 16.00. Now, when I add all these up together, that's going to give me 82.02 grams per mole of sodium acetate in a C2H3O2. All right, now let's take the 112 grams. We're going to convert it into moles. 112 grams of NaC2H3O2 times 1 mole of NaC2H3O2 divided by 82.02 grams of NaC2H3O2. So this is going to cancel out, and of course this is going to give me exactly 1.36 moles. Now, what I'm going to do is I'm going to take that 1.36 moles, and I'm going to use molality. So we've got molality here. And we're going to get the molality, which is going to be 1.36 on the top. And now remember that I have 1.65 liters on the bottom. So that remember that 1 gram equals 1 milliliter, right? So 1 gram is equal to 1 milliliter. So this is going to equal to in kilograms. Let's see here. So let's see. We got liters. So there's 1,000 milliliters in a liter. So that means this is going to be 1,650 grams on the bottom here. Now when we change that into kilograms, so to make that kilograms, we need to put a decimal point right there. So our new molality is going to be 0.82. That's our molality. So again, we had to convert liters into milliliters. That turned into grams. So let me show you how we did this. We take 1.65 liters and we change it into milliliters. That would make that 1,650 because you have to move the decimal this direction. So 1,650 milliliters is equal to 1,650 grams, but we need to use this in kilograms. So then we have to move the decimal back 3 spaces, just like this, to give me 1.65 kilograms to do molality. Because remember that molality is equal to moles of solute over mass of solvent in kilograms, right? So that's why we had to change this grams into kilograms. And that gives us our new molality, which is 0.82. Well, that's it for this lesson, guys. You be snarly, and we'll see you back here at Lucene Chemistry.